Okay, and then the last thing is what we call identity matrices. And so this letter I indicates the dimensions of the matrix where the rows and columns are exactly the same. Now there's a reason why we call these identity matrices, because if you multiply an identity matrix, it doesn't change with anything. You're going to get exactly the same matrix back. And so if you notice, the ones are on the diagonals. And so for each row, there's a 1 and then zeros. Okay? And so I'll just show you how this is applied using a 3 by 3 identity matrix. And then this is basically all we're doing in a day. Okay? So this is a 3 by 3 identity matrix. Notice the ones are from the top left diagonal to the bottom right. All right, so if we multiply this by x, y, z, and notice in the first row, the x is going to multiply with 1, and y and z are going to multiply to 0, so this is going to give us x. Whereas in the second row, the y is going to multiply to the 1, and the x and z are going to multiply to the 0s, so this is going to give us y. And in the third row, the z is going to multiply to the 1, and the x and y are going to multiply to the 0s, so this is going to give us z. That's why it's called an identity matrix. So this is the same thing as multiplying by 1. Or I shouldn't say the same thing. It's the equivalent. It's not because this is called a scalar. But it's equivalent to multiplying the matrix by a scalar of 1. It has the same result.